So hello and welcome everyone. My name is Michael Wessely. I'm a postdoc in Stefanie Mueller's HCI engineering group at MIT CSAIL. And today's talk is about ChromoUpdate, fast design iterations with photochromic color textures using grayscale previews and local color updates. I did this work together with my amazing colleagues from MIT CSAIL and from Skulltech. So at first, a little recap on what these photochromic multicolor textures actually are. So we presented in 2019 a project Photochromelion that used photochromic materials and ink pretty much that you can just like spray directly on the surface of various objects. And then you can reprogram the appearance of these objects using light projections. So you can see here how this looks like. So after projecting a set of red, green, and blue light patterns on it, you can create this colorful texture that you see right here. Then you had to go through an erase step using ultraviolet light. This is increasing the saturation of this photochromic material to 100%, so pretty much making it black again. And then you can project another completely different texture on it. For example, this black and white zebra pattern. So, but as you can see in the upper right corner, this procedure is not instant. It takes a specific amount of time. In this case, for example, 15 minutes per side or 60 minutes for all 4 sides. So, since this is a little bit too long for really fast design iterations where you just want to see directly how does an object look like and maybe you want to change something, we implemented 2 new methods. So, and these 2 new methods are on the one hand grayscale previews that only require 60 seconds to reprogram the appearance of an object. And the second one are direct texture to texture updates that are 11% faster than the color transfer methods in Photochromelion. So, and to show how this looks like and what this actually is, I want to directly start with an example, and let's start with the grayscale previews. So what you see right here is a phone case that we coated with this photochromic material, and by projecting ultraviolet light on it, we can reprogram its appearance in just 60 seconds. So and once this projection is finished, the object is ready to be used. So you can take it out directly and test it and see how it looks like with the phone inside under different lighting conditions and so on and so on. And the second method that we implemented are direct texture to texture updates that do not require this erase step in between as a Photochromelion, and that are faster. So in which kind of scenarios is this useful? So for example, if you want to have quick and daily updates. So here we implemented a notification mug that has a list of the meetings that you have for the day and also the weather forecast. And now imagine that 2 hours pass, 2 of the meetings are over, so you want to update it with a new texture that has these meetings crossed out and also the weather changed, so you want to also update the weather to it. And you can do this with our system directly, without erasing the texture that you had before, but directly going from the previous texture to the new texture, on average 11% faster than a Photochromelion. So let's talk a little bit about the working principle of these photochromic materials. So as I mentioned already, we use ultraviolet light to increase the saturation of this material. So here are cyan, magenta, and yellow photochromic dyes. And when we apply ultraviolet light on it, it changes from an unsaturated state, which is neutral or transparent, to a saturated state where we can see the colors cyan, magenta, and yellow. In previous work, we used a UV light source, so a UV LED. So pretty much a point light source that just illuminated the entire object. So we had to go through an entire erase step, saturating it completely, going to black, and then using the DLP projector to selectively desaturate the cyan, magenta, and yellow color in this photochromic coating to achieve a specific texture. In our new setup, we replaced the UV LED with the UV projector. And this has an important implication. And this is that we can now control both the saturation with UV light and the desaturation with RGB light pixel-wise, locally, and very precisely at high resolution. So both of these projectors are full HD. So, and this is how our entire setup looks like. So we just take these 2 projectors and place them in front of our rotation platform. And then all you have to do is just place your object on this rotation platform, and the system is ready to update the appearance of this object. So in summary, I presented today grayscale previews that can reprogram the appearance of an object in 60 seconds and direct texture to texture updates. So let's talk a little bit about like the next steps in this work. So what are the challenges and opportunities? And while it is already much faster than in previous work, it is not instant. And I have like here an illustration from Claytronics that nicely like shows like what our future research vision is. And this is going from fast updating to real-time texture reprogramming, where the change in appearance of an object is as instant as it is in the digital world, like when you change the texture of a digital object, for example. So, and with this, I want to end my talk. Thank you very much for being here, and I'm happy to answer questions.